Hello everyone. Today's lesson is on how to create and interpret a scatter diagram. Before we start, and as a reminder, scatter diagrams are useful when you want to study the relationship between two variables. As an example, I have prepared some data that are about the sales of bottles of water at a convenience store during the month of August. So you can see on column A the days of the month from day 1 through day 30. Column B displays the recorded temperatures in Celsius, the highest temperatures in Celsius for each one of those days. And column C shows my sales, how many bottles of water I actually sold on each particular day of the month of August. So that's the relationship that I want to study as an example. The impact on the temperature recorded through each day of August on my water sales. Obviously, you can use any other set of data to analyze anything else you would like to. For example, you could study the relationship between your marketing expenses and your sales. Or you could, for example, study the relationship between the number of attendants in a call center and the problems resolution at your company. So there are many different ways and different types of data that you can actually compare against. For our example, I'm using a very simple approach here, and we can move on and start building our scatter diagram. It's a very easy task in Excel. You want to simply select the two sets of data that you want to work with. In this example, I have selected all of the temperatures on column B and all of the water sales, the bottles of water that I sold on column C for each one of the days in that particular month of August. Once you have selected the two sets of data, you want to go to your charts menu. I am using Excel for Mac here, so you may see some small differences between Windows version or even an earlier version of Excel, but it shouldn't be too many differences. So under your charts menu, you want to go into Insert Chart and pick Scatter or Scatter Diagrams. And with the very first option, a very simple marked scatter. Click on it and you have your scatter diagram. So let's enlarge this window here so we can see it better. And let's do some work on this graph. So the very first thing that I see is a positive relationship. And what does that mean? It means that as my x-axis increases, which is my temperature, my y-axis also increases, which means I have a positive correlation between the temperatures outside and my water sales. And there are a few things that we can still do on this graph to give us even more insight. For example, if you click with the right button of the mouse on top of any of the data series here, and if you choose the selection or the option Add Trendline, you would add a trend line, as you can see here, which is a linear trend line where all the data series most attached to. So that trend line means that all of those data points are centered around it. And on the same window here, you can also display the equation of this relationship on the chart. You can click on type and choose linear as I've done here, and under options you simply click and check the box for display equation on chart. Okay, so let's understand what we can actually do with this equation. I can see that my y variable, which is my water sales, depends on my x. And this is a concept for SCADA diagrams, dependent variables and independent variables. My dependent variable in my example here is my water sales. My water sales depends on the temperatures. I cannot say the opposite. I cannot say that the temperature or the weather condition depends on how much water the population drinks. And that's basically the difference between a dependent variable and an independent variable. And the neat thing that I can do with this equation is to use it to estimate values for y, my water sales, based on any value for x. So for example, let's assume that I wanted to estimate how many bottles of water I would sell if the temperature outside would reach 35 degrees. As per the equation that you see right here, I can do equal to 2.5 288 times 35 degrees, hypothetically speaking, minus 21.515. And there we go. I would sell, hypothetically speaking, based on the equation on the regression analysis here, 67 bottles of water. And that's how you can use that equation. The other thing that we can do here is to calculate the correlation coefficient. The correlation coefficient would give you a more precise indication of how strong or how weak this correlationship really is. We already know it's a positive correlationship because, as I mentioned, as x increases, y also increases. You can see here on the chart. But let's see exactly how strong or how weak this correlation really is. In Excel, there are different ways of doing this, but you can simply type in any cell equals to, the function is correl, C-O-R-R-E-L. You can open brackets, and the first thing you need to do is to select array 1, or your first set of data, which is right here, temperatures, comma, and select array 2, my second set of data. Close brackets and hit enter. 0.91. This table is showing how this correlation coefficient can come about. If you find a correlation coefficient that it's around 0 or 0, it means there is no correlation whatsoever. One thing has nothing to do with the other. If it goes from 0 to 0.5, it's a slight or moderate positive correlationship. Between 0.5 and 1, it becomes stronger. Our number here, 0.91, shows that this correlationship in particular is very strong. On the other hand, you can also have a strong negative correlationship. If your x-axis increases and your y decreases, then you have a negative correlationship. And you apply the same formula to calculate that number or that coefficient, but the number would come out negative. In our example, I came with 0.91 as my correlation coefficient. In a nutshell, that's how you can create a scatter diagram and interpret in Excel without any specific macro or its specific add-ons. It's a powerful tool. It's one of the 7 quality tools that you can use to compare and study any set of 2 variables and understand the correlationship between the 2 variables.